Okay. So, still Unit 3. We call it mass and weight. If you're taking notes, I hope you are. Yeah, you should take notes. Okay. Let's say we have an unsuspecting student all of a sudden falls down a steep hill, and now they're just falling. Maybe not a steep hill. Falls out the window, whatever. Okay. They'll be safe, though. Don't worry. All right, so here we have the student. They are falling downward. Right? What force is acting on them? Gravity. Gravity. Just the force of gravity. We're going to ignore air resistance for a moment here. Okay? So just the force of gravity is acting on them, right? Right? So if I go through Newton's second law, F net equals ma. Oops. Right? We end up with an equation that tells me Fg is going to be the mass times what's this person's acceleration if they're falling? 9.8 downward, right? So I get this equation, Fg equals m times 9.8, right? Right? And that's on Earth. If they're falling on the moon, what does the 9.8 turn into? 1.6, something else, right? So this equation is specific for Earth. If I want to make a general equation, we have this. Right? Notice no vectors because this is the magnitude of the force of gravity. I'm not going to put any signs on my G, so that way when we plug them into Newton's second law on different problems, we don't put the negative sign in there twice. Okay, does that make sense? Okay, does that make sense? So this right here is the force of gravity. Now some of us have been using this all day, we have no problem. Okay. Now let's say that same student ends up falling. Oh goodness, I can't draw a head. I tried to draw an 8. I'm going to draw a snowman or something. And they land on a bathroom scale. Okay? They land on a bathroom scale. What does the bathroom scale measure?
Something bigger than 40.
We're assuming they hit it already. The scale survived, not just standing there. Okay, this is not the moment of impact. This is a few seconds after impact. Okay? So what does the scale measure? Weight. So this scale tells us our weight. Right? Let's say the student was 50 kilograms. What does the scale read? Okay, Richard says 50 kilograms. John says 50 times 9.8. Who's right?
What did it mean? Pounds.
Right. Sergio says, wouldn't it be in pounds? Pounds is U.S. customary. Is pounds a force or a mass?
I'm saying because like every scale I see is pounds.
I know, but that's U.S. customary. Okay, we're working SI base units. Is pounds force or mass?
Mass. I mean, if you go to
Okay.
Europe, it's like
Pounds is a force. So this scale reads in forces. Now you can switch your scale over to kilograms. If you switch your scale over to kilograms, then it's finding your mass. But that scale will only work where?
America.
No. It'll only work on Earth. Okay? Because what the scale does, if we switch to kilograms, all right, now it's finding your mass. It's taking the gravity out. It's doing a division problem for you. Okay, I wish the scale had a Newton setting. That'd be really cool. All right? If I took that same scale to the moon, would it read correctly? No, because it's assuming that I have a gravity of 9.8. So if you step on the moon, on the scale on the moon where gravity is 1.6, all right, it's going to read your mass as a lot lighter, or a lot less than it should be. So this scale reads a force. Okay, Richard, you look like you don't believe me.
I do not.
I think you're still unsuspecting, or you're still cautious. So why does it read a force? Well, what's pulling down on the person on the scale? Gravity. Okay? Nope. Okay. What's pushing up? What's pushing up? Normal force. Now, the way a scale works, it is designed to record the normal force needed to support you. That's what the scale reads. What's this person's acceleration at this point? 0, right? So if I go with Newton's second law, we know F net equals ma, right? We know the net force is really normal minus gravity equals ma, right? Right?
Yeah.
So then my A is 0, right? Force normal minus force gravity equals 0. Force normal equals force gravity. Right? Does that make sense, guys?
Yeah.
Yeah? So, we said this scale measures our weight. So this force normal right here is what the scale outputs as weight, which some physics books call W. So then I can rewrite this as W equals, what's force gravity? mg. Notice I have no vectors on there. Okay? So the weight the scale reads is going to be the person's mass, 50, times 9.8. Okay? So, are weight and mass the same thing? No. Weight is a force. Mass is the amount of matter. Okay, does that make sense? Okay. Any questions? Any questions?